Hello friends, welcome to my channel Computer Science Lectures. Today I am starting new series for the subject discrete structures or mathematics. Our first topic will be mathematical logic, and in that topic we will see prepositional logic. Prepositional logic is a collection of declarative statements that has either a truth value true or a truth value false. Examples of the prepositional are Jawaharlal Nehru is the first Prime Minister of India. It rained yesterday. If x is an integer, then x square is the positive integer. Some examples of statements which are not prepositions. Please report at 11 a.m. sharp. What is your name? Preposition consists of prepositional variables and connectives. We denote the preposition variables by P, Q, some kind of letters, etc. The connectives connect the prepositional variables. In below example, you can see that lowercase p and lowercase q represents some prepositions. So means you can say that p and q are prepositional variables. So in below example, p represents in the preposition India is in Asia. Q represent uh, preposition 2 plus 2 is equals to 4. In, in prepositional logic, generally we use 5 types of connectives, which are disjunction, or we can call it as or, which is denoted by reverse caret. Second one is conjunction, we can call it as and, which is represented by caret sign. Negation or not, and fourth one is implication or if then, which is denoted by implies sign. Fifth one is if and only if, which is denoted by is equivalent to sign. Some basic operations we can do on prepositions are: first operation is negation. Negation means opposite of original statement. If P is a statement, then the negation of P is denoted by negate P and read as it is not the case that P. So if P is true, then negate P is false and vice versa. Truth table of the negation operation is shown in the image. Consider the preposition P. When the value of preposition P is true, then the negation of preposition P will be false. When the value of preposition P is false, then the negation of preposition P will be true. Another basic operation is conjunction, or we can call it as and, represented by caret. It means ANDing of two statements. If P and Q are two statements, then P and Q is a compound statement denoted by P caret Q and referred as the conjunction of P and Q. The conjunction of P and Q is true only when both P and Q are true, otherwise it is false. The truth table for the conjunction operation is shown in the image. Consider the preposition P and Q, and out in third column the output is given for the P and Q. When the value of P and value of Q both are true, then the output of P and Q is true. When the value of P is true and value of Q is false, then output of P and Q is false. When the value of P is false and the value of Q is true, then the value of P and Q is false. When the value of P is false and value of q is also false, then value of p and q is also false. Another basic operation is disjunction, or and we can call it or, represented by reverse caret. It means ORing of two statements. If P and Q are two statements, then P or Q is a compound statement denoted by P reverse caret Q and referred as disjunction of P and Q. The disjunction of P and Q is true whenever at least one of the two statements is true, and it is false only when both P and Q are false. Truth table for the disjunction operation is shown in the image. There are two prepositions represented by P and Q, and the output of P or Q is given in the third column. When the value of P and Q is true, then the output of P or Q will be true. When the value of P is true and value of Q is false, then value of the output of P or Q will be true. When the value of P is F and the value of Q is true, then the output of P or Q is true. When the value of P is false and the value of Q is also false, then P or Q will give output false. Another basic operation is implication, or if then, denoted by imply sign. If an implication P implies Q is preposition. If P, then Q. It is false if P is true and Q is false. The rest cases are true. Truth table for the implication operation is shown in the image. Consider the preposition P and Q again, and the output of P implies Q is given in the third column. When P and Q both are true, the P implies Q gives true value. When value of P is true, value of Q is false, then P implies Q gives output false. When the value of P is false, value of Q is true, then P implies Q gives value true. When the value of P is false and the value of Q is false, then P implies Q gives output true. Another basic operation is if and only if, denoted by is equivalent to sign. P is equivalent to Q is biconditional logical connective which is true when P and Q are same, that is both are false or both are true. The truth table for uh, uh, if and only if operation is shown in the image. Consider P and Q both are prepositions, and when the third column gives the output of P is equivalent to Q operation. When the value of P and Q both are true, then the output of P is equivalent to Q will be true. When the value of P is true and value of Q is false, then output of P is equivalent to Q will be false. The value of P is false and the value of Q is also, if Q is true, then the output of P is equivalent to Q will be false. The value of P is false and the value of Q is false, then the output of P equivalent to Q will be true. So these are some basic operations. In the next video, we will go through some more terms in mathematical logic. We will try to solve some operations related to that terms. If you like this video, please like, share and subscribe, and give your feedback in comment box. Thanks.